So today we are starting with the increasing decreasing function, and in that we have already done that a function is said to be increasing if f dash x is greater than 0, or if f dash x is greater than 0 increasing means f dash x is greater than 0. So both way it is valid. Same way decreasing, if it is f dash x is negative, if f dash x negative, it is decreasing. That way you should know the result. Now coming on the question, how we'll do it, just check. Find the interval, first question right now please. Find the interval in which the function fx is equal to minus x square minus 2x plus 15 is increasing or decreasing. Find the interval where this function is increasing, where this function is decreasing. That we should identify. Function is given minus x square minus 2x plus 15. Find the interval where it is increasing, where it is decreasing. So to get that, first I go for f dash x. When you do this, what the derivative comes? Minus 2x minus 2. Then we write for increasing. We should have f dash x is positive. Already I told you. Function is said to be increasing if we have f dash x is coming greater than 0. So that means we'll say f dash x is coming greater than 0, or I should say minus 2 times x plus 1 is coming greater than 0. Minus if you remove, that is means we are dividing it by minus 2, then it will become reverse. So x plus 1 is coming less than 0. Or I should say x is less than minus 1. Therefore, what I should say, fx is increasing on x belongs to. Now it says x is less than minus 1. This is minus 1, so less than minus 1 means goes this way. So fx is increasing on x belongs to. It will go from minus infinity to minus 1. Same way for decreasing, when I say f dash x has to be less than 0. Or I should say minus 2 times x plus 1 is less than 0. When you divide it by minus 2, it has already come out to be x plus 1 is coming greater than 0. Or I should say x is greater than minus 1. Therefore, what I should say? Therefore, fx is decreasing on x belongs to. It says x is greater than minus 1. Greater than minus 1 means this side. So it will go from minus 1 to infinity. So this way you will be having the question. If it is increasing, x should be less than minus 1 means minus infinity to minus 1 it is increasing, and minus 1 to infinity it will be decreasing. That you should keep in mind. Now coming on second question please. Fx is equal to 2x cube minus 9x square plus of 12x plus of 15. Find the interval where it is increasing, where it is decreasing. Find the interval where it is increasing, where it is decreasing. This is the question we have. My question is, find the interval where this function is increasing, where this function is decreasing. It's a polynomial, means we are going to discuss it for the complete real number. Just like the previous question, it was linear function. It was quadratic, sorry. So that is after derivative converted into a linear function. So that was completely real part discussion. This way also, it is also going to be a real part discussion. So again, we go for derivative first. f dash x. What it will come? 2 3s are 6 x square minus of 18x plus of 12. 6 will be common. Left is x square minus 3x plus 2. Or it will come out to be x minus 1 into x minus 2. Then we should say for increasing, f dash x has to be greater than 0. Right? That means what I should say, 6 times x minus 1 into x minus 2 is coming greater than 0. Where we have to check now where it is positive or negative, we are wanting plus here. So we'll say on the number line, the points are 1 and 2, where they are going to change its value. When you take the value less than 1 means maybe 0, maybe minus 1. So when you put it 0, it is minus, and it is also minus, so it come out to be plus here. When you take between 1 and 2, means more than 1 but less than 2, then it will be plus, but this will be minus. So it will come out to be minus here. Then we go above 2. Above 2 means it will be plus, so net is plus. And as we are asking increasing functions, this quantity has to be positive. Where it is positive, from this interval to this, and then this to this. So therefore, I should say fx is increasing on x belongs to. It goes from minus infinity to 1 union to 2. Same way we go for decreasing. For decreasing, f dash x has to be negative. Or I should say 6 times x minus 1 into x minus 2 is coming negative. Where it is negative between 1 and 2. Therefore, what I should say, fx is decreasing on x belongs to interval 1 to 2. That is the answer. So decreasing, this is the condition. Increasing, this is the condition. It's only the inequation you should know how to solve it and how to differentiate. Only these two things you should know. Next question, please. Find the interval in which the function fx is equal to x plus 1 whole cube into x minus 3 whole cube is increasing or decreasing. Find the interval where this is increasing, where this is decreasing. So first we should go for it. F dash x is equal to, what it will come? 3 times x plus 1 whole square into x minus 1 whole cube plus. Then come out to be x plus 1 whole cube into 3 times x minus 3 whole square. Now what it will come? 3 is common, x plus 1 whole square is common, x minus 1 whole square is common. Then what left here? It will left x minus 1 and here it will left x plus 1. Or I should say 3 times x plus 1 whole square, x minus 1 whole square, and this will be what? Only 2x. Sorry, something wrong we are doing here. This was x plus 1, x minus 3 whole square. So it will be x plus 1 whole square, x minus 3, and this will be x minus 3. So what it will come now? 2x minus 2. Is it clear? And then 2 can be also taken common. So left is 6, x plus 1 whole square, x minus 1 whole square, x minus 1. Then we go for increasing.
But it will be x minus 3.
Which one? This one, na? For increasing, we have 6 times x plus 1 whole square, x minus 3 whole square, and then x minus 1 coming greater than 0. Now, if you just think about greater than 0, one thing is clear, this is clearly a positive number, it never be a negative case, any number you put. This is also going to be positive every time because this is also a perfect square. 6 is already a positive number. So that means only the portion left is x minus 1 which will decide the sign. This is always plus, this is always plus, this is always plus. So only this is to be greater than 0. So I should say x minus 1 has to be greater than 0. This is your number line. It is 1 here. It says x is greater than 1. 1 se bada here. So therefore, what I should say, fx is increasing on x belongs to 1 to infinity. Clear? Same way for decreasing. F dash x has to be negative. That means again we should say 6x plus 1 whole square, x minus 3 whole square, x minus 1 is coming negative. This is positive, positive, so I got it x minus 1 is coming negative. Or I should say x is less than 1. Therefore, what I should say, fx is decreasing. When x belongs to less than 1 means it will go from minus infinity to 1. That is x. Is it right? So this way you should have this question. Next question, please. Find the interval in which the function fx is equal to 4x squared plus 1 by x is increasing or decreasing. Find the interval where this function is increasing, where this function is decreasing. That is the question. Fx is 4x squared plus 1 by x. Find the interval where this function increases, where this function decreases. This you can write as 4x plus 1 by x is your function. Now that means f dash x, if I take, it will come out to be 4 minus 1 by x squared. Now for increasing, f dash x has to be greater than 0. Or I should say 4 minus 1 by x square has to be greater than 0. X square is the LCM, it will be 4x square minus 1 has to be greater than 0. Now if you want this quantity to be a positive number, then either both should be plus or both should be minus. Here this is already a positive number, we know it, because x square is here, but this we can decide. So here in this case 4x square minus 1, if you want this to be positive, simply I should say 4x square minus 1 has to be greater than 0. Or I should say this as 2x minus 1 into 2x plus 1 comes out to be greater than 0. And when you have this linear pair 2, x is half, it is going to change its value, it is at minus half. So here I say minus half, this is plus half. When you take the value less than minus half, maybe it is minus 1, minus 2 or minus 3. So if you take it minus 2, then it will be negative. This will be also negative, so net come out to be plus. Between minus half and half, we have 0. If you put it 0, it is minus, it is plus, so it will come out to be minus. And in third case, when it is above half, it will be both plus. So it is coming plus here. So this means what you should have now, we want positive number, it will be minus infinity to minus half, union half to infinity, it is increasing. So we should say thus, or therefore fx is increasing on x belongs to minus infinity to minus half, union half to infinity. Same way when you go for decreasing, what change will be here? This will be a negative value, this will be a negative value, this will be a negative value, then this will be a negative, because negative means 1 plus 1 minus, so numerator is already negative. Denominator is positive, but numerator is always negative. In this case, because you want the result to be negative. So if you want this to be negative, this quantity is negative. That means this has come out to be negative. So if it is negative, we want where it is negative. It comes between minus half and half. It is coming negative. So we should say, therefore, fx is decreasing on x belongs to minus half to half. That is the answer we have. So we will say decreasing will be in between minus half and half, and if it is beyond minus half this side or half this side, then we will say it will be increasing. So this way, whenever polynomial functions are there, you can have the increasing, decreasing function. Now